This is Math 2 Final Review, Unit 4. Everyone's on Unit 4. Before I start Unit 4 with you, bless you. When I went over this with you yesterday, I neglected to give you the answer for Part C.
Wow.
I know. Okay, so S prime, R prime, and T prime. This was just, guys, this was from yesterday's part. This was Part C from number 12. I didn't realize I did not give you guys, and I messed up on that one right there, that I did not give you guys the answer. Let's see. R is 4, -5. 0, -2. No, we're good. All right, so right there, one more time, that's the answer for 12C because I forgot to give it to you yesterday. All right, moving on. 14A. Did anybody use a different set of numbers than what we put on the board other than the 3, 4, 5? Nobody used a different set of numbers than 3, 4, 5? Gentlemen, ladies. Okay. 3, 4, 5. Who can explain why? Oh, did you use a different set? Okay, give me your set of numbers that you used.
12, 14, 15.
Okay, hold on. Say it again.
12, 14, 15.
Okay, so let's check. Is 12 plus 14 greater than 15? Do you guys agree or disagree? All right, what would the next set be? 12 plus what? And is that greater than 14?
Oh, yeah.
Yes? All right, and then what's the last set? We did 12, 15 plus 14. Okay, so we did 12 and 14, 12 and 15, and now you said 15 and 14. And is that greater than 12? Yes, so it's a side, those could be side lengths of any triangle. Can anybody tell me the 3 you used for it to not be a triangle? Yes.
9, 14, 15.
9, 14, 15. And it says explain why not. So let's try it. 9 plus 14, is that bigger than 15?
Yeah.
All right, so why doesn't it work? Because we have to keep checking. Let's do 9 plus 15. Is that bigger than 14?
Oh, yeah.
And what's the last set? And is that bigger than 9?
Yeah.
So would this side work for a triangle? But we want it to not work for a triangle. It's okay. So let's get a different set of numbers.
16, 14, 15.
16, 14, 15. Greater than, I think that would still work.
Yeah.
Okay, so let's start over.
2, 3, 5.
Yes.
6, 9, 15.
6, 9, 15. Okay, would that be one that would not work? Okay. Let's test the first set. Is 6 plus 9, what is 6 plus 9?
It's 15, exactly.
And can it be exact?
No.
No, it has to be greater than. So right there,
144.
1, 4, 4 would also not work. Would work. 1, 4, 4, 8. I believe that would work.
Yeah, I would.
All right. Okay. So we're good with that one. 15A. The answers for 15ABC are 8, 4, 7. How did you guys do on those?
Good. Very good.
And then 16 is C.
Yeah.
All right. I'm going to at least give you the formulas here. You double the mid-segment equals the base. These two are congruent, so 3n plus 3 equals 19 minus n. This one, what did you guys do for this one? What equals what?
5 plus 18. 5 equals 3.
Now, did they give us any congruent markings there?
No, with the top one.
The top ones. If this is a perpendicular bisector, that means it is an isosceles triangle. if it's perpendicular bisector goes through the opposite angle, I'm going to flip it this way. If your perpendicular bisector goes through the opposite angle, it is an isosceles triangle. All right, what I suggest you do here is label your angles. What side here is your smallest side? 12. What angle is opposite side 12? So that means R is your smallest angle. Thank you. What side here is your medium side?
18.
What angle is opposite side 18? So that means that is your medium. Please stop the talking. What side here is your largest? PR, which is 20, and opposite the 20 is Q, so that is your large. If you compare those, you can answer the question here. I'm going to continue. Okay. This first one is true for all, true for some, not true for any, and then this one true for all. I know I checked yours. This one, though, should be true for all. All right. Next one. When you plot A is -5, -2. B is -1/6, and C is 3, -4. All right, and then you go through, and to find the midpoints, you use the midpoint formula. So right now I'm just doing plotting the points. But right here where it says find and label the points, blah, blah, blah. So it's the midpoint. Midpoint formula is when you add your x values together and divide it by 2. Add your y values together and divide it by 2. That's your midpoint formula. If you do that for each one, you get D is -1, -3. And you get E is 1, 1. Was anybody able to look? I saw a few of you looking up your formulas. Was any of you able to get that? Good. And that's good that you guys are actually using the formulas the way, or your notes the way you should. A few of you said yes. Yes, some of you said no. Shame on you. Okay. Next one. Mathematically show they are parallel. What formula do we use to show things are parallel? Slope. y2 minus y1 over x2 minus x1. You find the slope of AB, you find the slope of DE, and the slope should come out to be the same. I will tell you right now, for those of you that have done it, or when you go through and do it, the slopes for both of them should come out to be 2. When you do your work should look like this, the way they looked in our notes and when we did quizzes. When you do the slopes for both of them, they both come out to be what? 2. All right. What formula do we use here to show the length of one is half the length of the other? Distance. Big square root. Yes, this is the skeleton piece, and then I'm going to do it flip-flop from what we usually did, x2 minus x1, y2 minus y1. Usually I did the x first, the x is first, and the y second. Does it matter if there's addition right here? Is 5 plus 3 the same as 3 plus 5? Yes. Addition is commutative. I just flip-flopped them. Okay. When you use this formula on D, E, and AB, please stop the talking. The length of DE comes out to be 2 root 5. And the length of AB comes out to be 4 root 5. Is 4 root 5 twice as big as 2 root 5? Okay. Number 19. E is 0 in. And F is MN. The slopes for each one come out to be 0. I will talk more about this one tomorrow because we may not have time today, but I will just explain more. All right, flip over to the next page. Last one, the answer is D.
D.
All right. Shall I go over this one before flipping back?
Yeah.
Okay.
No, I think I figured it out.
Okay. Please stop. Jim claims that these two triangles, ABC and triangle CDA, are congruent. Choose which would not be enough information to prove that the two triangles are congruent. Gentlemen, put that away. Turn around and paying attention. All right. I'm going to go through each one. First one, AD is parallel to BC and AB is parallel to DC. Is that enough to prove the two triangles are congruent? Okay, let's check. If this is parallel, then these angles are congruent. Do you agree? Yes? If this is parallel, then these two angles are congruent. And reflexive property, what do I have? Angle, side, angle. Angle, side, angle. Does everybody see that? I'm going to erase that because I need to go on to check the next one. Are we good? Okay, part B says the two triangles, that ABC is a rotation of CDA. Would that mean they are still congruent?
Oh, yeah.
Yes, because rotation is a rigid motion. Remember, rigid motion preserves congruency. Right? If I rotate a picture around, it's still congruent. Okay. AD is congruent to BC, and AB is congruent to DC. Why is that enough information to say the two triangles are congruent? Reflexive property, side, side, side. Does everybody see that? Yes? All right, let's check the last one. It says AD is congruent to AC, which is congruent to CB. I'm going to cover, in this triangle, I only have two congruent markings. Do I have any angle markings? Okay, this one, same thing. Just two congruent side markings. Do I have any angle markings? Do I have anything that is just side-side congruency? Is side-side enough? No, so letter D is the answer. Questions?
No.
All right, let's flip back over to this page. Shall I go over 17? Do you guys need help with 17? Bless you. What about 18?
I think we're getting there.
Which one? 17. Okay. D is a point. Please stop the talking. Consider all triangles that satisfy the given information. D is a point on the triangle ABC. There's the point D. AB is congruent to AC. What kind of triangle is this? It's a big triangle. What kind of triangle is this? Isosceles. The measure of angle BAD is congruent to the measure of angle CAD, or they're equal. What is AD called? An angle what? If these two angles are the same, AD is the angle bisector. Guys, knock it off. All right. We learned that if we have an isosceles triangle, the angle bisector is also the what bisector? Perpendicular bisector. Do you guys remember that? It's in your notes. If you have an isosceles triangle, your angle bisector is also a perpendicular bisector. So even though they didn't give us that information, should we know it? Okay. AD is perpendicular to BC. What did we just say? Is that always true? For all isosceles triangles where there's an angle bisector. The measure of ABD, that's this angle right here, is less than BAD. Do we have enough information to know which angle is bigger?
No.
No, so we have to say true for some, because it could be, it may not be. The measure of angle ACB, that's this angle here, equals half the measure of angle ABD. What do we know about these two angles if this is an isosceles triangle? These are the base angles, right? They're congruent. So is one half the other? Ever. If they're equal to each other, there's no way that one's half the other, so not true for any. And the last one, is BD half the length of BC? Yes, because we said these two are congruent, it's half, so this is half of the full length, so true for all. Questions? All right, when we come back in tomorrow, I am going over 19. Would you guys also like to see number 18? Or parts of it? Try it on your own. I gave you formulas and I gave you answers, so try it on your own the best you can. All right, that's it.